Hey everyone, this is Mrs. Miller, and I just wanted to talk to you a little bit about the immune system and specifically about the microorganisms that are out there that can trigger our immune system. But I'm not just going to talk about the bad today, I'm also going to talk about what is good about some of these microorganisms. So let's take a look. So we have three kingdoms that can impact us and that also exist as microorganisms. So we're going to start out with fungi. Fungi, I think most of us recognize as these little mushrooms. There's a lot of good about fungi. They are decomposers. They're used in the production of food. We talked a lot about that in our taxonomy unit. But they do also disrupt equilibrium by causing disease. You know, whenever you see mold growing somewhere, like the bread mold, fungi can also get in your lungs and cause pneumonia. It can cause things like athlete's foot and ringworm. Our next kingdom of microorganisms is Protista, and I have some pictures here. This is an algae called Stentor. This is a paramecium, and then this really interesting looking thing is called a slime mold. So these are helpful because they are producers. They're also used in food production and then the making of lots of different commercial products that we use every day. They can also cause disease. There are several diseases that are caused by Protista: malaria, dysentery. There is also these issues of algal blooms. And what that is when an algae just grows and grows in a body of water so much that it actually starts to deplete the nutrients from that body of water. Some of you may have seen this if you've ever been out in like rural areas, out in the country. Sometimes you'll see ponds, that are just covered by this like green film, and that is an algal bloom. Now, bacteria is what we're going to spend the most time on. Now, not all bacteria is bad. Bacteria lives in and on you all the time. It helps you to digest your food. It functions as a producer and also as a decomposer. We use them in cleaning up oil spills. We use bacteria to make certain foods. Bacteria is used in the production of yogurt and cheeses. They also can actually help us stay healthy. They help us to absorb nutrients and to absorb vitamins. So bacteria are very helpful to us. But they can also disrupt our equilibrium by causing disease. So I have here several different examples of bacteria: Streptococcus, Staphylococcus, botulism, Salmonella, and several others. And then the last microorganism that I want to talk to you about today is actually not a microorganism at all. Viruses are not actually considered to be living. And the reason for this is because, if you think back to the 8 characteristics of life, all living things are made of cells. Well, viruses are not made of cells. Viruses are typically just composed of some DNA and some protein. They don't actually have cells. Another characteristic of life is that living things can reproduce, and viruses cannot actually duplicate themselves on their own. They have to take over a host cell in order to reproduce. So let's take a look at how that works. So what I have here is the 2 different life cycles of a virus. So we have what is called the lytic cycle. In the lytic cycle, the virus can attach itself to the cell. This is actually a bacterial cell. There are viruses that infect bacteria. The virus attaches itself to the cell and injects its DNA, which then takes over the cell, and it sort of directs the cell to produce all these new copies of the virus. So the cell just sort of becomes this little virus replicating factory. And then at some point, all of those viruses will burst out of the cell and go off looking for new cells to infect. And so actually, whenever you have a viral infection, it's not the virus that necessarily that makes you sick. It's the destruction of the cells by the virus. There's also a cycle called the lysogenic cycle. Now, this is a type of viral reproduction cycle that sort of lays dormant in your cells for a long time. So the DNA is inserted into the cell, but then it incorporates itself into the cell's DNA so that every time that cell reproduces, it's also making a new copy of that viral DNA. Then at some point, something can trigger that virus to remove its DNA from the host cell, where it will then enter the lytic cycle. And so what you have is that instead of just one cell making lots of copies of a virus, you have hundreds or thousands or maybe even millions of cells making copies of a virus all at once. The best example of this is the virus that causes shingles. Now, this virus causes chickenpox as well, which most of you probably haven't had because you got a vaccine. But if you're my age, they didn't have a chickenpox vaccine. And so I actually got the chickenpox as a kid, had to just get over it and get better. But that virus then lays dormant in your cells, and any kind of event, especially stress, can actually trigger that virus to re-emerge as the disease shingles, which I actually got in 2020. And it is a disease that sort of presents itself like chickenpox. You know, you get the rash, but it's much more painful. And so that's one of the reasons that you see advertisements urging people who are over the age of 65 to get their shingles vaccine, because it's most common in people who are 65 and older. But people like me can actually get it when they're younger, because again, it can be triggered by any sort of stressful event. Now, the last thing that we want to talk about today is, what do we do with these microorganisms? Well, I want to talk to you about antibiotics. Antibiotics are chemical compounds that inhibit the growth of bacteria. And most of them do this by breaking down the cell walls of the bacteria. We talked about the discovery of penicillin, the first antibiotic. The scientist Alexander Fleming, who almost accidentally discovered that this mold was preventing the growth of bacteria. And from that, he was able to isolate a compound that stopped the growth of bacteria. So what you see here on this slide are discs of antibiotics. The white cloudy space that you see is actually the bacteria Staphylococcus aureus. And so then you can see varying rings around each of the antibiotics. Those clear rings are called the zone of inhibition. And so what you see here is that each of these antibiotics is able to prevent this bacteria from growing anywhere that you see that clear space. But antibiotics only work against bacteria. And this is why it's so important when you feel sick and you go to the doctor and they say, well, it's probably just a virus, but here are some antibiotics. That actually should give you some pause, because one of the things that has become really scary in our time is the emergence of bacteria that are resistant to antibiotics. And some of the reasons for that are people taking antibiotics when they shouldn't, people not finishing the course of their antibiotics. And then there's also some use of antibiotics in commercial products like food that we eat, although this has been much more regulated. But all of these things can lead to bacteria developing resistance. And what that means is that the bacteria is no longer affected by the antibiotic. So that was just a quick rundown of a lot of the different microorganisms that we interact with in our day-to-day lives. I hope that it was helpful, and I'll post these notes to Google Classroom. Make sure that you take the quiz to let me know what you understood, okay? Have a good one.